talking about rational functions. When it comes to rational functions, base word of the word rational is ratio. What is a ratio?
A relationship between two things.
Yes. Often written as a fraction. A rational function is a fraction function. It's a function written in the form of a of x over b of x, where a of x and b of x are polynomials. The reason that we jump to chapter 7 after chapter 5 is because of the connection to the polynomials. Yes, you will go back and talk about, I believe, both 5 and 6 in Advanced Algebra B, but because of the relationship to polynomials, chapter 7 makes more sense to go directly after chapter 4. Now, today we're going to talk about rational functions that are more in the reciprocal function form, which is just a real basic rational function. Whose parent, which is the parent function technically of all rational functions, is f of x is equal to 1 over x. When we talk about these reciprocal functions, their graph has a name. Similar to linear functions are lines, quadratic functions are parabolas. Reciprocal functions graphs are hyperbolas. And a hyperbola almost looks like two parabolas that are kind of crooked and on the same graph together. I graph f of x is equal to 1 over x. It looks like this. Now, as you look at this graph, first I'm going to look at this graph looking towards the left and to the right. You're going to notice that as it goes on both sides, it's kind of leveling off, going towards that same horizontal line. In this case, going towards the x-axis. If you look up and down, you're going to see similar to the y-axis. It's kind of leveling off, going towards that y-axis. This graph, the parent function, will never touch the x and the y-axis because on the x and y-axis of this graph is something known as an asymptote. Now, you've talked about asymptotes before. It's been a minute. Would have been 9th grade the last time you talked about an asymptote. But an asymptote is a line that a graph approaches but never touches. And reciprocal functions have two of them. Rational functions in general can have up to an infinite amount of them depending upon how complex the polynomials are in the numerator and denominator. Reciprocal functions have one that originally is on the x-axis and one that's originally on the y-axis. Note I said originally. The vertical one, the one that hangs out on the y-axis. Vertical lines are x equal to a number, in this case, x equals 0. While horizontal lines are y equal to a number, in this case, y equals 0. Yes, the x and y seem backwards, but they are not backwards here. All x's are the same on vertical lines. All y's are the same on horizontal lines. That's why the x and y seem like they're backwards with vertical and horizontal lines. Those asymptotes tell us about the function's domain and range. Domain is what you can put into a function. It's the x's that can go into the function. If I look at the x's on this graph, my graph is going to go all the way to the left, it's going to go all the way to the right, and it's going to hit every number in between except it has to jump over the asymptote. Which means my domain is all real numbers except x is not allowed to be equal to 0 because that's where the vertical asymptote is. Range is similar. My graph goes all the way up, it goes all the way down, it hits everything in between with the exception of the fact that it has to jump over this horizontal line. So the range is all real numbers except y is not allowed to be equal to 0. 0 because that's where the horizontal asymptote is. Now when we graph these functions, we're going to look at them in what's known as asymptote form. Okay, I typically like the door closed, but it's way too warm. Asymptote form looks like f of x is equal to a over x minus h plus k. Does anything look familiar about this? There's plus k. What else is there? Minus h. What else is there? A. A, h, and k are back. What does a control on a function? What type of transformations does a control? Vertical, what's? Vertical something or vertical something? Stretch and shrink. AKA compression for shrink. It's a vertical stretch if the absolute value of A is greater than 1. It's a vertical shrink if the absolute value of A is less than 1. We do the absolute value of it because we ignore the negative. Because what does a negative A do? Flips it. It does a reflection specifically. Across which axis? Yes, the x-axis. When A is less than 0, when A is negative, it flips it over the x-axis. going to come back to this. When you flip a hyperbola across the x-axis, traditionally a hyperbola is going to be in the positive region of the graph, quadrant 1, and quadrant 3 because that's where negative x's and negative y's go. If you flip it over, it goes into these two regions, making kind of that U shape, or that double U shape going towards one another. Okay, that's what A does. What does H do? Yes, it's the translations, specifically right or left. It goes to the right when you subtract H. Goes to the left when you add H. K also translates, but which directions? Up and down. Goes up when you do what? Add K. Goes down when you subtract K. Notice there's not a B. B can be looped into A, and that's what we're going to do in this chapter. If their B pops up, I'll show you how to deal with it. So today we're going to sketch the graph. As we do that, we are going to state what transformations the graph underwent, as well as state the domain into the range. Make sure you are reading instructions. It is not always going to ask for you to tell about the translations or the transformations. Sometimes it's just going to say graph it and tell me the domain and the range. You can always state the transformations, but make sure you're stating them when necessary and you don't have to when it doesn't say it. First one, g of x is equal to 3 over x plus 2. What do you see happen to this graph? Up 2. What else? Vertical stretch, factor 3. There can be up to 4 transformations that happen on these graphs. Up, down movement, left and right movement. Did this one go left and right? No. Vertical stretch or vertical shrink, and a reflection. Did this one reflect? No. We got all the transformations. So we're moving on to sketching it. Now I look at the translations to kind of figure out how to draw my axis. I'm going to need a little bit more room upwards on this graph. You don't have to do that. I just kind of do that to help myself out. When you are sketching your graphs, if you are counting by anything other than 1 on your scale, I expect that you write your scale on there. If you are counting by 1s, I will assume the scale. You don't have to write it if you don't want to, in other words. When you're graphing these, the first thing you should graph are the asymptotes. The asymptotes should be dotted lines, one vertical, one horizontal. Now when I take a vertical line, traditionally starts here on the y-axis. You're not going to notice a stretch or a shrink. You're not going to notice a reflection. You are going to notice movements, translations when it comes to the asymptotes. A vertical line, are you going to notice it moving up too? No, which means my vertical asymptote is still here. It didn't really move. Vertical lines, you're not going to notice up and down movement because lines go forever. Are vertical lines x equals or y equals? X equals, if it didn't move, what number? 0. That entire line has x values of 0. Okay, horizontal axis, or axis, asymptote is what I meant to say, is typically on the horizontal axis. Am I going to notice it moving up too? Yes, horizontal lines you'll notice moving up and down. Vertical lines you'll notice moving left and right. If I move it up to, where am I located? Where y is 2. Now, once you get to this point, the vertical stretch and vertical shrink of a graph, you are barely going to notice them. They don't do a whole lot of movement. Because if I show a graph, there's the parent function, there's one with a stretch on it. There a whole lot of change happening? No. So I don't pay that close of attention to the stretch or the shrink on the graph. So when it comes to the graph, you need to graph them in the right spot. That's the key thing. Has to go in the right location. If it did not flip over, it typically goes here and here. Did this one reflect? No, which means it's still going to go here and here, but not actually here and here. It moves with the asymptotes. So it's going to go in this region, do not cross the asymptote. And in this region, do not cross the asymptotes. Get close to them, but do not cross them. Ta-da, there is your graph. Don't forget domain and range. Again, domain and range start the same way. All real numbers except. What is the domain not allowed to include? Correct. All real numbers except x is not allowed to be equal to 0. So x not equal to 0. What is the range not allowed to be? Not this time. 2. It's not allowed to be the asymptotes. So y is not allowed to be equal to 2 because that's where that horizontal asymptote is. So far, not too bad? Hopefully. They will get a little more challenging than that. But there's nothing going to be crazy about the stuff you see today. We got 2 more examples. First, we're going to talk about the transformations we see. Allie, what's one transformation you see this graph undergoing?
Down 2. Or down 3.
It's moving down 3. Andrea, what's another one you're seeing? Yes, it's flipped across the x-axis. or reflected across the x-axis. Speaking of that one, this negative right here is the same as a negative being on the top of the fraction with a. So that is one that people tend to miss. But a negative here and a negative up top are the same thing when it's just a single number up top anyway. Kenzie, what's the last transformation it underwent?
Left 2.
Move to the left 2. Okay, so when I make my graph, I'm going to give me a little more room downwards, a little more room to the left. I'm going to count by ones because the numbers are plenty small. When I have a vertical asymptote, which direction will I notice it moving, Gracelyn? Vertical lines you'll notice moving up?
No.
Left and right. So I'm going to move left 2 with the vertical asymptote. Drew, what is the equation of this asymptote? These are equations. X equals is not located at 0. X equals -2. Be careful with the left and right. People tend to miss the positive and negative piece. Aiden, horizontal asymptote. How am I going to notice it moving?
Down 3.
I'm going to notice it moving down 3. Cadence, what's the equation of that line? Y equals -3. Keep an eye on the positive and negative. Okay. You get your asymptotes, and then I said the next thing you got to pay attention to is where the graph is going to go. It's always going to go in opposite corners. These two or these two? Option 1 or option 2? Option 2, because it flipped over the x-axis, which means instead of being in these two, it's going to end up in these two regions. Again, get close to the asymptotes, but do not cross them. That's what it looks like when it gets reflected. Kristen, what's going to be our domain?
All real numbers except x doesn't equal -2.
You got it. Brooke, what's going to be our range? Good. Still doing okay? The last one is the one that looks different. The last setup is going to be what makes them a little bit more challenging sometimes. Notice anything about this one? It looks different than the other ones. It looks different than the other ones in the fact that it's got an X up top and it's got a number being added to said X up top. This is not asymptote form. When it's not in asymptote form, you cannot go directly to the transformations because you don't know what they are. When you don't know what they are, when it's not in asymptote form, you're going to divide. Can I do synthetic division, dividing this by this? No, because to do synthetic division, the binomial you divide by, in this case it would be the 2x minus 6, would have to have a leading coefficient 1 and degree 1. It's got an exponent of 1 on that x, but it doesn't have a leading coefficient of 1, so I have to do long division. Thankfully, these long divisions are not going to be particularly challenging. They're not going to be long. 14x plus 8 goes here, 2x minus 6 goes here. I'm not missing any terms. What do I have to multiply by 2x to get 14x? 7. And then off to the side, 7 gets multiplied by what I'm dividing by. And I get 14x minus 42. And in long division, do we add or subtract? Subtract, but the easiest way to subtract is to distribute that negative. So I put the negative there, that becomes a positive, and then I add. Those cancel out, and I get 50. Isn't 50 already the remainder? Yeah, there's not a whole lot of dividing going to go on, which means our function, g of x, is equal to 7 plus 50 over 2x minus 6. If I flip that around, 50 over 2x minus 6 plus 7. Is that asymptote form? Not quite. It's close. It's close, but it's not quite. Sometimes it will be. A lot of the times it will already be in asymptote form. Asymptote form does not have a number in front of x. This does. So we got to deal with that. Here's the nice thing. You always can divide it off of that denominator. Specifically, I factor it out. Factor it out, I get x minus 3. In parentheses, we okay with that? Greatest common factor was 2. And in fact, I don't care what the greatest common factor is. I care that I divide out that 2, even if this ends up being a fraction. And do this. What is 50 divided by 2? 25. 25 over x minus 3 plus 7. That is asymptote form. Oftentimes you will not need to do this last step. The long division will be enough, or the synthetic division if you could do synthetic, but sometimes it won't be. Now we talk about our translations, and our transformations, I should say. Elijah, what's a transformation you see that happened? Yes. Christian, what's a transformation that you saw happen?
Right 3.
Yes. Kira, what's a transformation that you saw happen? In other words, what's that 25 doing? Is it a stretch or a shrink? Yep. Vertical stretch. Factor 25. The larger the factor, the more you would notice the difference from the graph, but I'm not going to worry about that. What's the only other transformation it could have undergone? Reflection. Did it reflect? No. Okay, I need more room up and to the right of this graph. Since I have to go up 7, I might count by a bigger number. I might count by 2s. And you could be lazy and label every other one when you're counting by something other than ones. Vertical asymptote. Am I going to notice it moving up or down or left and right? Left and right. Right 3. X equals 3. Which means the horizontal I'm going to notice moving up. Y equals 7. Make sure you give yourself enough room to actually see where your graph is happening. Option 1 or option 2? 1, 2. Where's my graph? If it didn't reflect, these places. Get close to the asymptotes, do not cross them. Garrick, what's our domain?
Equals are all real numbers except x is not equal to 3.
Caitlin, what is our range?
All numbers except y from
You got it. How feeling about graphing? Good? Bad? Somewhere in between? Anything? Couple thumbs ups, a lot of nothings. Okay. Our practice is on page 366. It is problems numbers 10 through 38, but only the evens.